this is Yoshinobu Matsuzaki. Again, I'm working for IIJ, Internet Initiative Japan. It's a pioneering ISP, and it's mostly focused on Japanese market, but we extended our backbone to US, Europe, and then Asia Pac as well. And we mostly focus on enterprise market. So our customers like government and the universities and big enterprises. So actually, we needed to provide IPv6 for our customer because, as I said, our customers are governmental, universities, and enterprises, and even including the network equipment vendors. They wanted to try IPv6 because they wanted to try or need to produce new product based on IPv6. So that's why we needed to provide IPv6. So we started our experimental service in 1999. So that time, it's just an experimental. So we don't have a proper implementation, but still, as our customer needed it, we offer our IPv6 service as an experimental. And then, year by year, we gradually enhanced our service as a production service. Then, provide our dual stack service for our customers, including the consumer market. We also providing the mobile service mostly for consumers, and of course, it's a dual stack. But actually, we have still some issue with iPhone, the Apple device, because we don't have a contract with Apple, and Apple and iPhone using IPv4 only PTP type for unknown thing, right? So even we provide a dual stack service for our mobile users, still iPhone use or see it as IPv4 only, unfortunately. So once Apple changed their mind and then decided to apply IPv4v6 dual stack for the usual or as a default, then we will see more IPv6 enabled users in our network, and also as a minor or smaller mobile networks as well. So our business model is just setting the boundaries, so capacity. So we don't care the protocol. Our customer choose. So either IPv4 only, yeah, it's okay, it's a customer choice. Or dual stack, or IPv6 only. Yes, it's up to the customer. And sometimes our customer asks IPv6 only. I actually asked the question, why did you choose an IPv6 only? And they said, yes, because we have a corporate policy for the IPv4 internet, and if it's an IPv4 address there, then we need to follow some instructions and some corporate rules. And if it's an IPv6 only, it's kind of exception, and they can use it freely without any restriction. So that's why the customer choose the IPv6 only at the time, but it's another story. So it's up to our customer, and we offer options for them. So we have several options. Then customer just check. Yes, we need a V4 and a V6. It's up to the customer. And next. Oh, wrong button. Oh, here you go. And of course, to provide an IPv6 service for our customer, our backbone should be enable IPv6. But as we started too early, that time we didn't have a production routers. We didn't have. So we needed to use PC-based router. And actually, the V6 stack was developed by our engineer. And then, gradually, software-based router support IPv6, like Cisco 7200. It's a software-based router, so any experimental future, first we introduce such a kind of model, then we use it for our backbone. But to have a separate, so two backbone is a bit complicated, and the capacity is pretty limited. So we decided to migrate to IPv4 and IPv6 dual stack backbone from 2005. So our backbone network, as I showed before, it's totally dual stacked. Addressing, as Jen mentioned, we use pretty simple and standard addressing in our network. /128 for router's loopback interface, and /64 for the point-to-point links, and sometimes we use 127 addressing. And for the enterprise customers, we assign /48, and the consumers, we assign /48 or /56, depending on the services and the And in our right region, there's a good document describing how to assign addresses for your customer as a right 690. So you can check this document if you are thinking about your addressing for the customers. In the IPv6 addressing, we have an interface ID. And we assign unique interface ID to every router to simplify our configuration. So our router uses an ID as an interface ID on every single interface. So we don't need to confuse about an addressing when we trace out from the host to destination. It's not correlated with IPv4 address, so it's unique in the IPv6 form. But we have an exception for those customer-facing interface, because we use a more pretty or human-friendly address for the customer-facing interface. And when we use a 127 addressing, of course, it's in some restriction there. We don't follow this scheme, but basically we are using the unique ID per router for the interface ID. Global unit just address is not necessary in the backbone link, as Jen said, but we assign addresses just in case, because we still using ping to check the interface availability. So that's why we configure global unit just address of each interface, just in case. But it's up to you. Link local, I know some operator decided to configure human-friendly address for the link local address, but we decided to not to touch as is. So router automatically generated its own link local address, and we are using it as is. Because most of the configurations, we don't need a link local address specification in the configuration. It's automatically used that. So we don't touch. But of course, in several cases, like an virtual address for the first hop redundancy, like VRRP or HSRP, we are using the X380:1 as a link local address, shared link local address, so that as a terminal, the computer can specify their default route to the easy configurable address. Route aggregation inside our network, we don't care that much. We allocated /56 for every pop, just in case, but we are not aggregating the IPv6 prefix in our network. because most of our routing information is carried by BGP, so we don't need to care that much. Routing protocol, we are using OSPF for IPv4. That's why we decided to use OSPF v3 for IPv6. But it's our case. You can choose your preferable protocol like ISIS. If we are using it already, it's perfect. And we are using the almost the same topology and configuration among the IPv4 and the IPv6 to simplify our configuration, to minimize operators' confusion. Router ID. So like an OSPF and the BGP, we need a 32-bit ID. In IPv4 world, we are using the IPv4 address of the loopback address. But if you have an IPv6 only network, you need to pick 32-bit unique ID for the router. But as we maintain dual stack back home, so we are still using the IPv4 address of the router's loopback interface as a unique ID of the router. IGP cost, as I said, we decided to use the same topology, same configuration, mostly same configuration for our routing protocols. So we decided to use the same link cost as IPv4 to simplify our configuration. And so far, it's working fine because we have almost the same peering relationship in each IXP. We have almost same traffic profile on IPv4 and IPv6. So that's why even we are setting the same link cost for IPv4 and IPv6, it's working fine. So if you have a different topology, IPv4 and IPv6 in your network, maybe you need to change or tweak somehow in your network. But once you have a totally dual stack backbone and totally dual stack peering with your partner, you are fine to use the same link cost, same IGP cost for your network to simplify your configuration. And for BGP4 Plus, so how to carry our IPv6 prefix in your network, we are using the same policy as IPv4. So we are carrying the BGP4 next hop as is. We don't touch. But you need to import the next hop network information into your routing protocol, usually into the IGP. Yes, we are importing certain prefix of IXP and peering connection information into our IGP. Also, we are using the BGP multipath for load sharing. Unfortunately, it's not the standard technology. It's not written in the RFC. So sometimes it's a vendor specific, but still it works. And most of the people using it, and it's actually useful. So we are using the same multipath topology as an IPv4. So far, it's working fine. Management, our router management port is dual stack, so we can SSH to our router from the stepping host only. So it's on the same policy as IPv4s. But other management services like authentication and SNMP and Cicero, NTP, flow export are IPv4 only so far. But it's not a customer-facing service, so it's okay so far. As I said, we are using ping. It's a old and still useful tool to check the availability. And then, as I said, we configure IPv4 address and the IPv6 address on each single interface. So the router now received twice as much ping. But then so far, it's nothing like too much. So router can handle such kind of the such amount of the ping so far. So working fine. This is our name server entry. So it's Eurostat. Because we are providing the IPv6 service for our customer, we need to use it, right? Otherwise, our engineer are not comfortable with our technology, and also our customer are not comfortable. So we are enable our V6 record on our zone, maybe 2000 or something. So we are one of the first customers of IPv6 service as an IIJ. Also, we enabled our enable IPv6 on our SMTP servers and the website as well. Also, we provide an IPv6 connectivity in our office network, so that an engineer got in trouble. Touch and feel, right? And yeah, that was 2000. But currently, even including the sales department and the legal department, each single office network is Eurostat. And so far, we have no claim, and people are using it without any doubt. So, as I mentioned, we have many academic customers and vendors, and they are using our service a lot. And we have a bunch of different services online. And sometimes we got the question when this service is going to be IPv6 enabled, so that as a customer they can schedule their V6 adoption. So we had a special web page to indicating when and how our service is going to be enabled IPv6. Based on that, our customer can schedule their plan to adopt or migrate. Maybe this is needed for this region as well, so that your customer can schedule their IPv6 adoption. But as our services are already V6 enabled and Eurostat, now the page is gone. This is a bit about the Japanese situation. So we have many FTTH users and 5G subscribers nowadays. And we formed a task force to measure IPv6 adoption in Japan. So that was formed by telecom operators, major ISPs, and including the governmental regulators as well. So we got together and shared some data among the telecom operator to see what kind of status we have and what kind of adoption level we have. So each year we publish this data to public so that people can see the situation in Japan. So that's my experience, and I hope it's somehow useful in this community as well. Thank you very much.